Okay, so our goal today is going to be to graph linear equations in slope-intercept form. So we had talked about, we plotted graphs. We plotted points the other day, and that's when we did the leaf plot. And that's going to come in handy today when we're working on graphing linear equations, because we're going to, again, have points to plot. So what is a linear function? It's a function where when you graph it, it's going to be a line. Okay, it's a straight line. If you can't take a straight edge and connect it, then your points are not going to be correct. Okay, that means you need to go back and fix it. If you can't connect all your points with a straight edge, then something's wrong in your graph. It can be represented also as a table, a graph, or an equation. Okay, the equation that many of you guys will remember is the one that's in the form of y equals mx plus b. Does that sound familiar? Y equals mx plus b? Yeah. Okay, so that's usually the one that you guys typically tend to remember. An equation is just one way to represent a linear function. Okay, so I put some examples there. It could be y equals 3x plus 4. If it says f of x, it's just written with function notation, but it doesn't mean anything different. It's the same thing as if I wrote y equals negative 7x plus 3. Okay, the independent variable, that's going to be the input or the domain, which are going to be your x values. We practiced that in 2.1 with coming up with the domain by looking at the x values of coordinate points. In science, the independent variable, that's what you usually change, right? You'll try it with this many things, you'll try it with this many things. And then the dependent variable in science, that's the outcome, the one that you measure and then record, and then you'll make your graph of it. But your dependent is just your output or your range, or with a coordinate point, that's going to be your y. The slope. Does anyone remember about slope? It does look like a fraction. Do you remember what's on that fraction? Starts with an R. Anyone remember?
Oh, run over rise?
Other way around.
Rise over run.
Rise over run. It's rise over run. Okay, so this is the ratio of vertical change to horizontal change. Okay, so it's often used, we use an M to talk about it. So M is equal to rise over run. The formula we use to find it is M equals, we use y2 minus y1 over x2 minus x1. Now, don't write those as exponents. You want to make sure they're written down below. They just mean that those are the two different y values. When we're looking at 2 points, you're taking the two y values. You have to assign a point 1 and assign a point 2. Okay? And it is important that whatever point you assign as 2 comes first both times. Okay? And you'll see that when we practice it. You may remember this symbol from, I believe, physical science, or if any of you have taken physics, but it's called delta. It's a triangle. You remember that? It means change. So change in y over change in x. That would also just be another way you could represent slope. Okay. The one we'll use most often there is that middle one, though, the y2 minus y1 over the x2 minus x1. That is something you guys will want to make sure you have memorized because you'll be using it all the time. Okay. The y-intercept is going to be where it's the point on the line where the line crosses the y-axis. The way this point is written is always 0, comma, y. It's always 0, comma, a number. Because if it has to be on the y-axis, you can't move left or right at all. You just have to move up and or down. Okay, so you're not going to move left or right at all. You're just going to move up or down, and that point would be on the y-axis. When we write our y-intercept, we have to write it as a point. We never write it y equals a number. Okay, that means something completely different in math. The x-intercept is the same idea, but this is the point on the line that crosses the x-axis. Anyone want to take a guess at what this coordinate point will look like? Yeah, x comma 0. In this one, we will move to the left or to the right, but we can't move up or down at all because then we would be off of the x-axis. We want to just be on the x-axis, so we need to move to an x, stay there, and not go up or down at all. Okay. All right, so if I find 2 points on my graph here, what I want to do is I'm given this graph, and I want to find the slope on this graph. So if I'm given the graph, I'm going to find a point where it crosses very nicely over a point. So like right here, see how that's at an actual point? See that? So I'm going to put a point there so I know what I'm looking at here. And the next one I would say is right here. I can see even another one right here. But I'm just looking for where I have a really nice point, okay, where it's crossing two lines. You see what I'm looking for? Okay. So then all we're going to do is we're going to find the rise over run. So it doesn't matter which point you start with, but if you start with the point on the left, your rise is going down. And when we go down on a graph, that number is always going to be negative. So we're going down 3. I have to double check because sometimes your scale is different. So I'm going from 5 to 2. That is down 3. So my rise is negative 3. When I go to the right, that is positive on a graph. So I'm going from negative 4 to 0. That's positive 4. Okay, so my rise over the run is going to be negative 3 over 4. So my slope here is negative 3/4. I have to reduce the fraction if necessary. Okay, I'm going to show you another way we could have done this. And how we'll still get the same answer, but our work is going to be a little bit different. If I would have started from this point and I went up, I'm going to come all the way back over to this point, the faraway point. So I would first have to go up. Up is positive on a graph. So I went up 1, 2, 3, 4, 5, 6. So my rise here over my run is 6 over my run. When I move left on a graph, it's negative, and I have to figure out how far left did I go. 1, 2, 3, 4, 5, 6, 7, 8. So I have negative 8. But the slope should always be the same on a line. So why is it that it's okay if I got negative 3/4 and 6 over negative 8? Yes, I have to reduce that fraction. So both of those numbers are divisible by 2. So if I divide the top by 2, I get 3. If I divide the bottom by 2, I get negative 4. Negative 3/4 or negative 3/4, it doesn't matter if the negative sign is on the top or the bottom. You guys had this exact question or something very similar to this on almost every single quiz on quizzes numbers 1 through 4, where you had two numbers that were identical and you had to tell me that they were, is it less than, greater than, or equal to? And those two numbers are equal. It does not matter if the negative sign is on top, down on the bottom, or out front. A negative is a negative that's to the left of 0 on a number line. Either way, this value is the same thing as negative 0.75, even though we don't use decimals very often in this class. Okay, but the value of it's the exact same. It doesn't matter where that negative sign is. Does that make sense? How you could have either of those answers? And they're the exact same. Okay, so the next thing that we're going to do is we're going to do this but from 2 points. So our points here, we have to label them. Which one do you want to be point 1 and which one do you want to be point 2? It does not matter. I usually just start writing x1, y1, x2, y2. And then what I'm looking for is I'm going to plug this into my formula. My formula says that to find slope, I take y2 minus y1 over x2 minus x1. And then all I'm going to do is fill in everything where it needs to go. So my y2 is labeled at 3 minus my y1. And you can even start by just writing out like this and then filling in everything. So that was y2. y1 goes right here, which is 9. x2 is labeled at 0. And x1 is labeled negative 3. Okay. The reason I like to put the parentheses there is because often people will forget that there is another negative there, and they'll see that subtraction sign and just write minus 3. And it doesn't turn into minus 3 because what happens when you subtract a negative? It becomes plus, right? Becomes addition. So on the top I have 3 minus 9, which is negative 6. On the bottom I have 0 plus 3, which is 3. Is that acceptable to leave my answer like that? No, I have to reduce it. So what is negative 6 divided by 3? Negative 2. So my slope here is negative 2. Okay. Let's see. If I would have labeled this one point as point 2 and this as point 1, that's okay. The only difference is I would have gotten 6 over negative 3, but I would have still gotten negative 2. Okay, so if you put it in the other order, it just the negative sign would be in the different place, but you'll still end up with the same answer. Okay. Example 2. How about you guys try that one on your own, and I'll walk around and see how we're doing. A lot of people got to this point right here. What is negative 5 divided by 0?
Nothing.
Is it? If I have 5 pizzas and I try to make them disappear because I have to divide them by 0, what happens to the pizzas? Huh?
I don't know. It's here. That's like 5 cents not.
If I take 5 divided by 0, what's my calculator going to tell me? Error. Okay? You cannot divide by 0. If you have something, we don't have magic powers that just says, poof, disappear. Okay? So because of that, you're not allowed to divide by 0. This answer is actually undefined.
Oh, I said no solution.
Similar, but it actually has to say undefined.
Oh, well.
Undefined. If this was the other way around and we were trying to do 0 divided by 5, now that answer, you can have 0 pieces. I'll share them with all of you people. You'll all get 0 pieces. Oh, you can't even see that. There you go. So you can have 0 on top of a fraction, but you're not allowed to have 0 on the bottom of a fraction. Okay, and if you do, we call it undefined. Okay, and I'll tell you a little story about skiing, because if you look at where these points are plotted, they're right on top of each other. One's at 1, -2 and 1, -7. So that creates a vertical line. Okay? Now slopes remind me of skiing, right? You ski down slopes, right? So if you have a slope like this, can you ski down it?
Maybe you could try.
Like this one? You can ski down stuff like that. Okay, let's say it was the other way. Oh no, that's the same way. Here we go. Let's say it was this way. Can you ski down slopes like that? Yeah, you can ski down those. So this is actually a positive slope because as you read it like a book, left to right, it's going up. Okay? If you read it like this, okay, this is a negative slope. I know it's the same graph. I'm looking at it in two different ways though. When you go read it like a book from left to right, that's a negative slope. So you can ski down slopes that are positive or slopes that are negative. Can you ski across a slope that looks like this? That would be completely flat and horizontal. Can you ski across something like that? Yeah, it's cross-country skiing, right? How fun is cross-country skiing?
Not far at all.
Zero fun, right? So this slope is 0. Because in that case, your rise would be 0. So you would have 0 over a number. When you do 0 divided by a number, you get 0. But yeah, cross-country skiing, think about that. When you think about the slopes, think about skiing. And when you ski across that, 0 fun. Sorry if I offend anyone that's a cross-country skier, but I think it's 0.
Our moms
Oh, I was about to say it. I'm just kidding.
All right, so then what happens, because on this one, your slopes look like this. Your graph is going to be a vertical line. Can you ski down something like that? Probably not going to live to tell about it. If you do live, you probably aren't going to remember it because you probably suffered a pretty bad concussion or accident. So your ski trip would be undefined. No one would know about your ski story because no one can remember it. Right? So that's why that one's undefined. So if you think about skiing, sometimes it helps you when you're thinking about slopes. All right, let's flip the page. So how do you use slope to graph? Okay, you can use the slope because slope is rise over run. So if you have one point, you can use the slope to tell you how to find another point. So we're going to practice that here. What is your rise on example 1? Your rise is 1. You're going to go up 1 or down 1 though? Up 1 because 1 is positive. So this would tell you to go up 1, right 2 because your bottom is 2, which is your run, and it's a positive, so we go right 2. So that's what we want to do with these ones. Now, if the negative sign is out front, like in example 2, it doesn't matter if that negative sign is out front. You can put it on the top, or you can put it on the bottom. Remember, as long as there's one negative sign, we know that that number is to the left of 0. So you can choose if you want to write it negative 3 over 4. You can choose if you want to write it as 3 over negative 4. Those three numbers are all equal. Now, depending on how you write it, might be a little bit different on how you're going to say your direction goes. Okay? Because if I write it like this, that would be down 3, right 4. So if I was here, I'd be going down and to the right with something that looks like that. How would I describe the next one, though? How would I describe it if I put the negative on the bottom? Yes, that one would go up 3, left 4. So that means I would be here and I go up and to the left. Notice, though, that they will create the exact same line. Okay, because if you go up and to the left, that's the same as going down and to the right. Example 3 is a little tricky because you can't see the run. What's the run?
1.
It's 1. If you think about this as 7 over 1, then your rise is 7, your run is 1. So how's this one going to move? Yeah, up 7, right 1. And then the last one, again, put it over 1. If there's not a fraction, just put it over 1. It's the exact same thing. So negative 3 over 1 moves down 3, right 1. Okay. Now, slope-intercept form. This is the equation that most of you tend to remember. Y equals mx plus b. Okay. Now, we have to know a couple key pieces of information, so we always write it with it. M is going to represent what? Slope. Notice it's right in the name, slope-intercept form. Your B also represents something. What does the B represent? It's right in the name. If M is the slope, B is the intercept. But you have to say which intercept. Is it going to be the x-intercept or the y-intercept? The y-intercept. Okay? So your y-intercept, and now we have to actually write it like an intercept, is 0, comma, b. So we're going to make sure we write it as a point. So if on a quiz I tell you to define slope-intercept form and state what the variables represent, this is exactly what you would write. Hint, hint, nudge, nudge, you might see that question on your quiz next week. Okay? You want to make sure this whole box gets written, because if you only wrote this part, y equals mx plus b, that would only get you 1 point. You have to tell me that your m is slope and your y-intercept is 0, comma, b. That would get you your 2 points. All right? All right, so how do you graph using slope-intercept form? Well, first you need to identify the slope. You need to identify and plot the y-intercept. So once you identify the y-intercept, you can put that point on your graph. Then you're going to use slope to locate more points. And once you have as many points on your graph as possible, you're going to connect all the points with a straight edge. Now I say use a straight edge because some people who try to sketch it, they won't notice where they had a mistake in their points. But if you're trying to use a straight edge and you can't connect them all, then you know that there's a mistake in your points. Because if you graph it correctly, you should be able to connect all points with your straight edge. All right, so example 1 here. What is the slope? Y equals mx plus b. What's your slope? 3. Okay, so we identified the slope. Next, let's identify the y-intercept, and we have to plot it. So what is the y-intercept here? 7 gives it to you, but we have to write the y-intercept as a point. 0, 7. Yep. You can't write just 7 there. It is 0, 7. So what we are going to do is we're going to plot that y-intercept. So 0, 7. So we plotted it. Now we can use the slope to locate more points. So how does that slope tell you to move on a graph? Remember, you can also think about it as 3 over 1. How does 3 over 1 move? How does that slope move? Up 3, right 1. Can I go up 3, right 1? I can't. So what am I going to do? We're going to go instead, since we can't go up 3, right 1, we're going to go down 3, left 1. And I'm going to keep doing that until I've run out of space on my entire graph. And then I'm going to use a straight edge. Once I have as many points that will fit, I'll use a straight edge, and I should, if I plotted all my points accurately, I should very easily be able to connect all of these with a straight edge, and I can. So that makes me feel a little bit better that my points were accurate. Okay. You could also make a table of values. You can always resort to making a table of values and plug in 0 and -1, -2, 1 and 2. Just plug in some values and just plug them into your equation. What is y when x is -2? 3 times -2 is -6. -6 plus 7 is 1. Plug in -1. 3 times -1 is -3. -3 plus 7 is 4. 3 times 0 is 0. 0 plus 7 is 7. 3 times 1 is 3. 3 plus 7 is 10. 3 times 2 is 6. 6 plus 7 is 13. So you could have also found a table of values that will always work if you're lost on how to use the slope and how to use your y-intercept. Make a table of values and plot the points. -2, 1. You're going to go left 2, up 1. Look, that's a point. -1, 4. Oh, look, that's a point. Okay, so those points made it on our graph. All right, last example for the day. Example 2, y equals -1/2 x minus 4. What is the slope? -1/2. And how about that y-intercept? 0, -4. Good job on making sure you say that as a point. Okay? So, what do I do first to graph this? I'm going to plot that y-intercept. So remember, I don't go left to right at all, 0, down to -4. There's that point. Okay, now I have to find more points, though. Yep, I could go down 1, right 2, or once I run out of space when I do it that way, where do I go? Up 1, left 2. Good. And that one would be off. Once I have all my points there, I'm going to use my straight edge and I'm going to connect all those points. I'm going to make sure I put arrows in both directions because I know that line goes on forever. After that page, you will see that you have classwork. So you're going to finish this in probably the remainder of the time. Okay? And then you have your assignment is after that. And on this assignment, there are some where you have to make a table. Okay, so I showed you how to do that too. All right. One that we didn't go over, though, that is on your assignment, is are the following coordinate points on the following line? If I give you a function, this is just like y equals 3x minus 12. Plug in the point and see if it works. If you plug in 0, is your y value at 12? And if it is, cool, that's on the line. Plug in -4. For y, do you get -24? And if you do, then that's a point. Plug in 3 for x. And if you get -3, then it's on the line. But if you don't, then it's not on the line. Is that okay? So that's the only thing on your assignment that we did not go over in detail. But everything else is on there, is in your notes.